Question. DS. Is x less than 0? Condition 1. X is less than 2. Condition 2. X to the power of 5 plus x plus 1 equals 0. Solution. Now we will solve this DS question using the variable approach. DS. One variable, question. Condition 1. One equation. Condition 2. One equation. DS question with one variable. Let's look at the DS question with one variable in the original condition. Now, one variable would generally require one equation to find the value of the variable. We know that each condition should give us an equation, and each equation should be able to give us the value of a variable. So, each condition should be sufficient independently, and we should logically get the answer D. Remember, the most likely answer is D if there is one variable in the original condition. Let's apply the 3 steps suggested previously. Follow the first step of the variable approach by modifying and rechecking the original condition and the question. We have to find out whether x is less than 0. Follow the second and the third step. From the original condition, we have one variable, x. To match the number of variables with the number of equations, we need one equation. Since conditions 1 and 2 will provide one equation each, D would most likely be the answer. Recall 3 principles and choose D as the most likely answer. Now, let's take a look at each condition separately. Condition 1 tells us that x is less than 2, and the question asks for x is less than 0. If x equals -1, we'll give an answer yes, while x equals 1, we'll give an answer no. The answer is not unique, both yes and no, so it's not sufficient. Since we know for sure condition 1 is not sufficient, and condition 2, x to the power of 5 plus x plus 1 equals 0 looks complicated, we are fairly safe in assuming the correct answer is B. In this case, we substituted a number in the condition 1 first because it looks easier. By substituting, we found both yes and no answers, which is why condition 1 is not sufficient. By applying the variable approach, we don't have to solve everything to figure out the answer. We just need to follow the logic. If we take the time to actually solve condition 2, which states that x to the power of 5 plus x plus 1 equals 0, this can be arranged to get x to the power of 5 plus x equals -1. Taking out a common factor of x gives us x times of whole x to the power of 4 plus 1 equals -1, which can be further rearranged to get x equals -1 over x to the power of 4 plus 1. Since the denominator, x to the power of 4 plus 1, is always positive, the answer x is always negative, because dividing -1 by a positive number always results in a negative answer. This satisfies x is less than 0. The answer is unique, yes, so the condition 2 is sufficient. Your confidence will be built up as you continue to use the variable approach. Condition 2 alone is sufficient. When we have one variable in the original condition, we need one equation. In this case, it is most likely that D is the correct answer. For some cases, A or B can also be an answer, as seen in this question. However, neither C nor E can be an answer. With condition 1 in this question, we know for sure that it is not sufficient. So B is most likely the answer, logically speaking. This is how we reach our answer in the DS section by using the variable approach method. Although we verified the answer by solving this complicated problem, we can just choose the answer B when we know for sure that condition 1 is not sufficient. The variable approach helps students solve DS problems quickly. This is the power of the variable approach. So B is the correct answer. Although the answer for this question is B, you should remember that choosing D will help you get more correct answers if you don't have enough time to solve the question, or don't know the answer in the actual exam. Answer B.